So we learned that. So these edge ratios are constant for the given angle. Okay. Let's take the given angle is theta. Okay. For the corresponding edge ratio, okay. For example, I am taking the edge ratio of the opposite side by hypotenuse, that is AB by AC. Okay. So that we are taking as a sine, right? Okay. So these ratios are constant for the different angles. Okay. So that if you know the angle, you know the edge ratio. If you know this ratio, then we know the angle. Okay. So the most commonly used angles I'm writing here. For all the angles, we'll be having the edge ratios constant. Okay. So for example, this angle is 30 degree. You have the edge ratio of 1/2. Okay. If this is 45 degrees, then this ratio is 1/√2. Okay. If it is 60 degrees, see, 60 degrees, then this ratio is √3/2. Okay. So like that, it has the different constant for the angle. Okay. So if you know this angle, then you know this ratio. Okay. Similarly, if you go on take the other ratios, like right adjacent side to the hypotenuse, okay, that is also related to the theta. And if you take the adjacent side, like right BCY and take the hypotenuse, okay, this we are denoting as a cos. Okay, here is the ratio for 30 degrees. This ratio is √3/2. Okay, for 45 degrees, this ratio is 1/2. Okay, similarly 60 degrees, this ratio is 1/2. Okay, so okay, if this ratio is coming like 1/2, then we will say that this is for 60 degrees. Okay, so you get these edge ratios for any angle by the graphical way very easily. Okay, so let's see how to get these edge ratios for the different angles. So let's take the graph sheet, or you can take the any plain paper also. Okay, so no problem. Okay, you can take the graph sheet or you can take the plain paper. Okay, let's mark point in this paper or graph sheet. Okay, so I'm just marking one point over here. So I'm just taking this point is A. Okay, and I'm dropping on a horizontal line. Okay, by using ruler. Okay, by using ruler, I'm just making a horizontal line. Okay, now take the protractor at the A. Okay, and you just mark the whichever angle you want to measure these ratios, like these edge ratios, like opposite side by hypotenuse. This all the ratios, right? It does not depend on the size of the triangle. Okay, only it depends on the angle of the triangle. Okay, for example, I want to measure this one for 30 degrees. Okay, I'm just marking the point here at 30 degrees. Okay, so I'm just marking the point 30 degrees here. Okay, and using your ruler, right, scale, you just join these 2 points. Okay, from the point A, just join. So now you have drawn 2 lines with the angle of 30 degrees, right? So this is the point A. So this is the angle 30 degrees you have drawn. Okay, now you can draw it any place vertical line. Okay, by using the again protractor, you can draw the vertical line from this horizontal line. Okay, so that it will form the 90 degrees at angle. Okay, so let's draw any vertical line anywhere. Okay, so it won't change these ratios accordingly with the size of the triangle. So that you can draw any place vertical line by using the protractor. Okay, let me draw at any place like this, something like that. I can draw it here, right? So I'm just drawing a vertical line here. Okay, similarly you can draw anywhere. It's okay. Just drawing another. Okay, let's mark these points. So this is the point B, and this is the point C, and this is the point B, and this is the point E. Okay, so now it formed the right angle triangle ABC. Okay, so at the angle, this is the now with the scale you measure this distance AB. Okay, and also you measure the distance BC. Okay, and also with the scale you can measure the distance AC. Now you know the AB distance and BC distance and AC distance, right? So that we can calculate all these angles. Okay, let's see. I have drawn very approximately here. Okay, so that it may not get the exact number, but if you draw it in proper scale and right, you will get the accurate number. Let's take AB is how much. So I'm just taking the units. It is 1 box, 2 box, 3, 4, 5, 6. Okay, I'm just taking 6. how much we have the vertical here. So 1, 2, 3, and it's around the middle of this, right? So it has some 3.5, okay. If you use the Pythagoras theorem, you can find the CSE, or you can measure with the scale directly, okay. You will get this distance around like 6.9 or 6.92. If you want to know the sin theta, okay, what is the sin 30 here? Okay, I'm just writing sin 30. It is the opposite side to the hypotenuse, right? What is the opposite side? That is here, mark with the point C, right? So the BC by hypotenuse is AC, right? So what is the BC? BC is 3.5, okay, divided by 6.9, right? So if you do this ratio, you will get like 0.502, okay? It is approximately, it's equal to 1/2, okay? So that's the reason it is sin 30 is 1/2, okay? So this, similarly, if you do it for the cos 30, okay? So cos 30 is the adjacent side to the angle, right? That is AB by hypotenuse. What is adjacent side? It is a 6, right? So 6 by, what is the hypotenuse here? 6.9. Okay. So if you do it here, you will get around 0.86, right? This is almost, the value is equivalent to the √3/2, okay? This 0.86 is √3/2, okay? You can check with your calculator. Okay, similarly, even not only this triangle ABC, okay, any triangle like vertically like ADC or any triangle if you take, right, you will get the same ratios. So you need to understand that it depends only on the angle, not on the size of the right angle, okay? So there's a tabulated, or in the calculator, right, you will be having these ratios for all the angles like 1, 2, 3, 4, 5, like that. For all the angles, you have these ratios. Yeah, if you can do this exercise, okay, if you have any questions, you can make in comments, okay? Graphical method to derive these edge ratios, okay?